Some summation to integral calculus. Some summation to integral calculus. This is the discussion that we are pursuing, and we will come to our problem. And the problem about where we are finding the solution is 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 2n minus 1. This is a very famous odd number addition. 1 plus 3 plus 5 plus 7 plus 9. But the result what we gave is surprise. No one would have ever dreamed that this is the result. What is the result? We have worked toward it in the previous session. 1 plus 3 plus 5 plus 7 plus 9, all addition of all numbers, the addition of all numbers, it result into a solution called n square. 1 plus 2 plus 3 plus 4 plus 5, I'm sorry, 1 plus 3 plus 5, this is the third term. 7, 9, 11, sixth term. Like that, this is n equal to 1, the number is 1. N equal to 2, the number is 3. N equal to 3, the number is 5. N equal to 4, number is 7. N equal to 5, number is 9, like so. So at the nth place, the number is 2n minus 1. What is the addition of this? And we have seen it, it is n square. And it is surprising to anyone, n square. Okay, if n is fifth position, then the total number addition will be n square. That will come as 25. 1 plus 3 plus 5, that will come as 9, plus 7, that will come as 16, plus 9, 25. Amazingly, all are, if I calculate, it will become a square of numbers. Amazing. At least I was highly surprised. If n equal to 10, then total addition will be n equal to 10 means the number at that slot, the 10th slot, second slot number is 3, third slot number is 5, at the 10th slot number will be 19, and total addition is 10 square, 100. Next slot 121, next slot 149, next slot 169. Amazingly. Anyway, I have not checked the actual result. I believe this is, anyway, we have computed it. I don't know what is the way that is it is being brought through the algebra. These are the algebraic equation that at any nth slot, the number is 2n minus 1. Any nth slot, the number is 2n minus 1. Okay, that is the scenario, 2n minus 1. Okay, if that is the case, then what will be the 2n minus 1? If slot number is 3, then the number belonging to slot number 3 is 2n minus 1. 3 into 2 minus 1, 5. 1, 3, 5. All right. If slot number 6, the number will be 11. 5, 7, 9, 11. 11 is slot number 6. What is addition of this? We have seen two methodologies. One methodology is repeated addition. Divide problem into n different parts and solve part by part. If someone has problem, 1 plus 3 plus 5 divide into n different parts. First part is 1, second is 3, third is 5th. Okay, let's make every part behave same. Then it will be 2x minus 1. All are 2x minus 1, where x is variable. 2x minus 1 plus 2x minus 1 plus 2x minus 1 plus up to n term. That can be rewritten as 2x minus 1 into x, where x is n. 2x minus 1 dx. 2x minus 1 dx, x is 0 to n. Then it will be x to the power x square minus x, 0 to n square minus n. This is the result we have seen through repeated addition. Then we went through successive approximation. Successive approximation is supposed to give exact result, and it would give result that is better than someone finds through the book. People generally they refer the book and they find the solution. Okay, people generally they refer the book and find the solution, and there they have proved in algebraic manner. I tried. What is the problem here in summation? Why we are bringing summation series? The problem here with the summation series is every summation has different solution. Anyone can try. Try 1 square plus 2 square plus 3 square plus 4 square up to 10 square. Try. Okay, then they will go with one kind of methodology to bring a algebraic equation 1 square plus 2 square. If someone try 1 plus 2 plus 3 plus 4, then different way. If someone try 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square, different way. If there are n type of summation series are there are n ways to calculate the summation of the series. Where all summation series are the net formula are being deduced differently, separately. Can we go a generic way to find the solution? And that generic way is calculus. Okay, calculus works in continuous function only. If there is a continuous function, calculus works there. If at any point, if this is x squared, I'm sorry, this is x axis, and this is a continuous function. Okay, if this is a continuous function, if this is a continuous function at any moment, okay, if consider this is a straight line, this is a straight line, this is x axis, and this is a straight line. If this is a straight line, then what is slope of this line at any point? Any point. Everywhere it is same. What I mean is take any point x and calculate y and divide y by x. Okay, this is a straight line. Okay, someone can hold like this. This is a straight line, exactly straight line. Take another y and calculate y by x, another y and calculate y by x. Everywhere y by x will be constant. Okay, everywhere. But if it is not a straight line, consider this is a curved line. Consider this is a curved line like this. It is a curved line. If it is a curved line, then what is y by x at any time? If this is y, this is x. This is y, this is x. Y by x is variable at different point. But we are not talking about, if I take any point x, then this is y. Y by x. This is not what we are taking. At this moment, here, here the height is y and x is x. This point, if I take a small section here, if I take a small section here, small section of this point, at around this point is x comma y. Here, if I take a small section around x comma y, and then in that small section of this line, small section, what is the variation in x I can see? If this is the point x comma y, this point is x2 comma y2, and this point is x1 comma y1. If I go from x1 comma y1 to x2 comma y2, where middle part is x comma y, okay, then what is the variation in x I am seeing? X2 minus x1. What is the variation in y I am seeing? Y2 minus y1. What is y2 minus y1 by x1, x2 minus x1? This shows what is the tangent. If I draw a tangent line at this point, if I draw a tangent line, then what will be the slope of that tangent line? We are not talking about this point means y by x. This is not we are talking. At any point, at any point, what is the tangent line? This tangent line will go like this. This tangent line, what is the tan theta? If you make angle tan theta, what is tan theta? What is delta y by delta x? Everywhere delta y by delta x will be different. We are not talking about full height by full width. That is not differentiation. So differentiation talks about the direction of line at any point. If there is a fluid that is flowing, consider this is a pipe, and this is a pipe, a fluid is flowing. So fluid is changing its direction. Earlier fluid is going like this, then going like this, then going like this, then going like this, then going like this, like this. Fluid is changing its direction. At any moment, what is the direction of the fluid? Direction means the fluid at any moment, if I say fluid is moving in a straight line, any moment, momentarily, fluid will move in a straight line, though it is not a straight line, but at any moment, it will behave in a straight line called local linearity. Like earth is flat. At any moment, earth is flat, but earth is not flat. Like that, it is not a straight line, but any moment, it will behave like a straight line. At that moment, what is, if I, that straight line, if I draw like this, that is called tangent, Then what is the angle of tangent with x-axis, tan theta, that is delta y by delta x around that point? What is the direction of the line at that point? That is differentiation. Whereas integration talks about area underneath it. If this is a curved line, that is a continuous line, what is area underneath it from point x1 to x2, where the equation of this line is fx. fx dx from x1 to x2, x1 to x2 will give area underneath it. Makes sense? Okay, these are the all functionality that comes in continuous function. There is a something called discrete function, and this is discrete function. There is a function called fx, function over x, and equal to 2x minus 1. This is what it is. 1 plus 3 plus 5, I'm sorry, 1, 3, 5, 7, 9, it is 2x minus 1. Where x is, if this is x-axis, this is x-axis. When x is 5, then number is 9. 1, 3, I'm sorry, x is 5, x is 1, 2, 3, 4, 5, x is 5. Then the number at this slot is 9. Slot means vertical. What is vertical at x equal to 5? 9. What is vertical at x equal to 4? Then it is 7. What is vertical at x equal to 3? Then it is 5. What is vertical at x equal to 2? 3. What is vertical at x equal to 1? 1. Height is 1, height is 3, height is 5, height is 7, height is 9 at x equal to 5. So this function, if I touch all the vertical, all the points, if height is 1 at x equal to 1, height is 3 at x equal to 2, height is 5 at x equal to 3, height is 7 at x equal to 4, height is 9 at x equal to 5. If I touch all the top point and draw a line, that is called function over x, and that is a discrete function. Discrete function means digital function. It has value at only at a whole number of x. There is no value at fraction of x. 1.1, 1.2, it is not there. This is called point mass function or discrete function. Okay, if I want this summation of discrete vertical, then I have to I have to transform this discrete function into continuous function. Okay, this is our research. This is not available in any of the book. Anyone can try. Okay. Now what you want? I want to convert this discrete function into continuous function. If I convert discrete function into continuous function, then continuous function can have two ways, one differentiation and one integration. If I calculate differentiation will give slope at every point, whereas integration will give area underneath it. Can I find summation of a series through area way? That is the solution. Through area way. What fundamental we have taken? Let's consider this is x equal to 1. Oh, this is fx. And it is a straight line. This is not, oh, I have two. I think I have two. Okay. Consider this is x-axis and this is function over x. And this is a straight line, whose slope is 2. Tan theta equal to 2. 2x minus 1 dy by dx will be 2, 1. Now when x equal to 1, then height is 1. When x equal to 2, height is 3. X equal to 3, height is 5. X equal to 4, height is 7. X equal to 5, height is 9. Okay. Now consider there is another function. This function is called fx, and this is 2x minus 1. There is another function called gx. This is a separate function altogether. This function is called gx function, and this function I don't know what it is. This function I don't know what is relationship between fx, that is a discrete function, and this continuous function. What is the relationship? Relationship is if x equal to 3, then height x equal to 3, then height is 5. Okay, then when x equal to 4, then height is 7. Now consider this area strip between x equal to 3 and x equal to 4. This is the area strip. If this area strip I go up and it hits gx continuous function, then what is the area underneath it? Limit x equal to 3 to 4 gx dx. Can this area between x equal to 3 and 4, this area can be exactly same as the fx at x equal to 3, that is 5. Okay, what do you mean? It is straightforward. If I take any x equal to x, then fx is 2x minus 1. This is what we are trying to say. Okay, at x equal to x and x plus 1, between this, if I take area, it goes and hit gx. This area, can it be exactly same as fx, that is 2x minus 1? This is what we have seen in the previous video. If that is like that, then fx equal to limit x to x plus 1 gx dx. In that way, I have to find gx. Can it be that I take left side? What do you mean by left side? Left side means I have x equal to 1, then vertical is 1. X equal to 2, then vertical is x equal to 1, vertical is 1. X equal to 2, vertical is 3. X equal to 3, vertical is 5. X equal to 4, vertical is 7. Can we go left side? What is left side? Consider x equal to 3, then vertical is 5. I'll go one back, then it is x equal to 2, then vertical is 3. Let's take area between 5 and 3 and let's proceed up, and it hits gx. Then what is this area? Area is between 3 to 5, limit 3 to 5 gx dx. Can this area be same at x equal to 5? Means left hand side area we are taking. If I say x equal to, x equal to 3, if it is x equal to 3, then vertical is 5, 2x minus 1. Okay, this height, that is 5, that is fx, this height can be same as area of gx from x to x minus 1, 1 back. This area in gx should be exactly same as the height at x equal to x. Yeah, what do you mean? Fx equal to x minus 1 to x gx dx. Is it possible? We'll try. Fx is 2x minus 1 equal to limit x minus 1 to x gx dx. If this way, if I'm able to find gx, then gx will have sub area. When x equal to 1, then one area will be x equal to 1 minus 1, that is 0 to 1 gx dx, 1 to 2 gx dx, and this 1 to 2 gx dx will be exactly same at height x equal to 2 fx. Area between 2 and 3 gx dx will be exactly same as the height at x equal to 3. Area between 3 and 4 will be exactly same as the height at x equal to 4. The last one, the area between n minus 1 and n with gx will be same as height of fx at x equal to n. Means summation x equal to 1 to n, sigma summation x equal to 1 to n. Okay, sigma summation x equal to 1 to n fx equal to 0 to, here it is 1 to n, but here it will be 1 minus 1, 0 to 1 gx dx plus 1 to 2 gx dx plus 2 to 3 gx dx. All sub area, 0 to 1 means one sub area. This sub area will belong to here fx of 1. 1 to 2 gx dx will belong to fx at 2. Fx at 2 will be area in gx left side, 1 to 2, like that. Area between n minus 1 to 1 n minus 1 to n gx dx will be same as fx at x equal to n. This, the left hand side, that is actually the summation is 1 plus 3 plus 5 plus 7 plus 9. It is same as 2x minus 1, 2x minus 1, 2x minus 1, where x is variable. It is same as sigma x equal to 1 to n fx. Fx is 2x minus 1. It is same as 1 plus 3 plus 5 if I set the value of x. Now 1 is 0 to 1 gx dx, 3 is 1 to 2 limit gx dx, 5 is 2 to 3 gx dx. Make sense? Last one is 2n minus 1 is same as n minus 1 to n gx dx. So if I take any value x at x equal to x, it will be fx 2x minus 1 will be same as x minus 1 left side, x minus 1 x dx dx. If dx comes in reality, if it is really real and it is true, then we can proceed upon the solution. Okay, we will try. I'm really sweating. But these are very intricate. Can we try finding this gx dx in this fashion? Yeah, certainly we can try. 2x minus 1 equal to limit x minus 1 to x gx dx. Gx dx equal to 2x minus 1. Gx will be fx equal to gx dx. Gx will be dfx by dx. In that fashion, dx will be 2. We'll try with 2. 2 dx, 2x from x minus 1 to x. It will come as 2x minus 2x plus 2. It will come as 2. Okay, answer is 2. We want 2x minus 1. This is called successive approximation. We approximate step by step and we proceed. 2x minus 1 equal to 2. Okay, if I settle down only in x, minus 1 just take it out. 2x equal to 2 means I have to multiply by x now to have the same. Here 2x, then it will be 2x. Right now 2. So we started with 2x. Now we will start with 2x square because I have to multiply x to balance both sides. 2x square integration, that is gx, now 2x square. 2x square integration will be 2x square by 2 means x square. From x minus 1 to x, it will come as x square minus x square plus 2x minus 1. X minus 1 whole square will be x square minus 2x plus 1. Outside minus means x square minus x square plus 2x minus 1. Okay, it will come as 2x minus 1. Here we want 2x minus 1 and it is 2x minus 1. Exactly. Can someone believe all? Okay, if gx equal to 2x, if gx equal to 2x, then we are getting both result. Here it is 2x minus 1, that is fx. Limit x minus 1 to x gx. I'm not able to believe it. And actually, I did not try it. Okay, x minus 1 to x gx dx. Gx is 2x. 2x square by 2, 2 gone x square. X minus 1 to x square minus x minus 1 whole square. That will be x square minus 2x plus 1. Minus is outside, minus x square plus 2x minus 1. Makes sense? Okay, that is gone, 2x minus 1. This side 2x minus 1, this side 2x minus 1. Amazingly easy. Gx is 2x. Can we try with the final integration? If gx is 2x, can we try with final integration? Yeah, we will try final integration. What is final integration? Final integration will be from the, now we have, this is x-axis. This is x-axis. Then consider this is gx and this is fx. Fx is a straight line. And we have started our calculation at x equal to 1 to x equal to n. At x equal to 1, height is 1. At x equal to 2, height is 3. At x equal to 3, height is 5. At x equal to n, height will be 2n minus 1. There are n vertical bar. X equal to 1 to n, now we have gx. But gx is divided into n different parts because there are n vertical. If there are three vertical and I am taking left hand side area because area will be between two vertical. So if x is 1, x is 2 and x is 3, then there are two sub area in between, one between 1 and 2 and another between 2 and 3. One sub area, another sub area, but I need to have three sub area. Each vertical will have one sub area. Then I have to go either right side or left side. If I go left hand side, then this is the sub area on the left hand side. This is the sub area on left hand side. So between 3 and 2, one sub area. Between 2 and 1, one sub area. And between 1 and 0, one sub area. Okay. Between 3, the fx at 3, x equal to 3 is 5. 5 correspond to sub area in gx between 3 and 2. 3 correspond to sub area in gx between 3 and 1. And then 1 height correspond to sub area between 1 and 0. So net I have to integrate it from 0 to 3, 0 to n. The net integration that will come here is 0 to n. Okay, what we want now? We want f summation x equal to 1 to n fx, that will be equal to full area, that is 0 to n. Here it is x is 1 and x is n, but here x is 0 and n. The left hand side area we have taken. 0 to n 2x dx. That will come as 2x square by 2x square n square. N square is the result. If people have watched our previous video where we had taken right hand side area and their integration limit was 1 to n plus 1, then gx was different, not this. And then we got answer as n square only. Here also we are getting answer as n square only. Okay, both are exactly same. Okay, someone can try third one. Someone can take it as an assignment. Try the third one. What is third one? Now people would hint in their mind. There can be third one. Third one is consider x equal to 1, 2, 3, 4, 5, 6 up to n. If x equal to x, then height is 2x minus 1 in fx. This is what is the summation, discrete summation we want. There is a gx like this. Hop. There is a gx like this. If there is a gx like this, then at x equal to x, height is 2x minus 1. Let's take how the width between two successive x is 1. X equal to 1, 2, 3, 4, x plus 1, x plus 2, like so. If there is a x for which vertical is 2x minus 1, if I take sub area in gx where there are n sub area belonging to n number of vertical, if I take x at x equal to x, then I have a vertical at x equal to x, vertical at x equal to 1 and vertical at x equal to n, and where the gap between each vertical is 1. If it is x, then left side can I take x minus half, and right side I can take x plus half, this sub area. In gx, this sub area, if I take n number of this sub area, that will start from 0.5 to 1.5, 1.5 to 2.5, and like so. If I take n number of this sub area, where each sub area will belong to the middle one x. So x minus half to x plus half will belong to vertical at fx at x. What do you mean? I am saying fx, that is 2x minus 1, equal to integration x minus half to x plus half gx dx. Here gx will come differently. Can we solve it? I believe we are running out of the time. So someone can try, or we can try. Okay, how much it will come? Let us start gx with 2x only, the way we started. With 2x only, because it will same story, we will start, it will come to 2x. So it will come at 2x square by 2. 2 to go on x square. X square limit is x minus half to x plus half. That will become x plus half whole square minus x minus half whole square. X square will go away. And then here it will be x plus 1 by 4. X plus 1 by 4 minus, and in bracket, minus x plus 1 by 4. Makes sense? So minus x, it will become 2x. 1 by 4 minus 1 by 4 will go away. Result is 2x. X this side and x this side. 2x. Wanted is 2x minus 1. We are getting 2x, means minus 1 I have to add now. We'll start with 2x minus 1. We'll try again. Integration will be x square minus x. Now limit is x minus half to x plus half. X square is settled now. X square will come as 2x, that we have already seen. 2x minus x minus, and instead of x I have to write x plus 1 by 2 minus x minus 1 by 2. X will go away. 1 by 2 plus 1 by 2, it will come as 1. Outside minus is waiting, minus 1. It is exactly same. Exactly same. What is exactly same? I believe it is 2, what we tried, I forgot. 2x minus 1. If I take again 2x minus 1, 2x minus 1, that will come at x square minus x. X square will be settled down as 2x, 2x, just 2x minus x, minus x if we take, then in bracket it will be x and half minus x and half, x plus 1 by 2 minus x minus 1 by 2. It will become 1 by 2 plus 1 by 2. 1. Outside minus is waiting. Minus 1. It is exactly 2x minus 1. Amazingly. So gx is again 2x minus 1. For final integration, we will start with 1 minus half, that is 1 by 2 to n plus 1 by 2. 1 by 2 to n plus 1 by 2, 2x minus 1. Integration will be n square, integration will be x square minus x. X square minus x, limit half to n plus half. Someone has to settle down. N plus half whole square will become n square plus n plus 1 by 4. Plus 1 by 4. Okay. Plus 1 by 4. Let's settle down the 1 by 2 together. So 1 by 2 x minus 1 by 4. N square 1 by 4 minus. So 1 by 4, 1 by 4 gone. And it remained only n square plus n minus x minus, and in bracket for x I have to set n plus 1, n plus half minus half. Gone. Only n will remain. Minus n will come outside. N square plus n minus n, n square. Same n square with different limit. Can someone believe on this? This is my question. If people remember, both places we have 2x minus 1 as gx. One limit is 0 to n and other limit is 1 by 2 to n plus 1. But as per calculus fundamental, both should result in same, and actually they resulted in same. And previous session we tried 1 to n plus 1, again n square. So n square is the solution. Please do not mind supporting us. +91 in the India country code 9483160610 is the telephone number. +91 in the India country code 9483160610 is the telephone number. Miracle of integral calculus. Not available anywhere else.